Hi guys, welcome back to lab. So today we're going to start by reviewing our results from the Kirby-Bauer test. So I have my gram positive and my gram negative here. What I'm going to do is measure my zone of inhibitions. So as you can see, the gram negative, which is the E. coli, has a lot clearer zones of inhibitions. And what I'm going to do is I'm essentially going to take my ruler, put it in centimeters, and then measure from boundary to boundary. So in this case, this one is tetracycline. For E. coli, the zone of inhibition is around 23 centimeters, 2.3 centimeters and 23 millimeters. So I'm gonna write that down on my task sheet. I'm gonna go around, measure all of my zone of inhibitions, and then put it on the screen for you guys. To give you guys another example, this is staph. What happened here is some of the zone of inhibitions kind of bled into each other. So what I do to measure these is I look for clear boundaries. So for example, I would measure ampicillin for staph from here to here. And that would give me a zone of inhibition of around 3.2 centimeters, 32 millimeters. And that's how I'm gonna go ahead and measure all of my zone of inhibitions. Okay, for the second part of the experiment, we're going to be vacuum filtering 2 water samples to see how many microplastics and what kind of microplastics are present in both samples. I'm going to start by vacuum filtering 200 milliliters of FIU pond water. So I'm going to grab my beaker. I'm going to go over here. I'm going to grab 200 milliliters of my FIU pond water. And then I'm going to go to my vacuum filtration set. Okay, so this is my vacuum filtration apparatus. So for this portion of the experiment, there's a few things that you're gonna need. A petri dish with a filter paper, some forceps, your pond water or whatever water sample you're using. And then the last thing you're gonna need is some DI water. So for this vacuum filtration, essentially what it does is it creates a vacuum and it filters out your water, and on your little filter paper, all of your microplastics will be left over. So to set this up, you get your filter paper, you peel it, and then there's 2 pieces in here. There's one with a grid on it and this. This is just a cover, so you don't use this, you use this. So to run this experiment, I open this. My grid side goes up. I place it there, and I place the lid back on it. All right, so now the next thing that I do is I have to make sure that my vacuum is working. So when I turn on my actual gas line, I should hear a very slight buzzing, which I'm not sure if you can catch on camera. And then I rinse my filter paper out with DI water first. Make sure that the water is dripping down. And then I take my actual water sample and I pass it through very slowly, taking little breaks in between to make sure the vacuum is working. If I were to just dump my entire water sample here, it would end up getting clogged, and then I'd have to wait even longer. All right, I let that filter through. And then once all of my pond water has gone through, I rinse with a little bit of DI water just to make sure all of the pond water is fully filtered. And then once I see there's no more droplets of water coming through, I turn off my vacuum. All right, so now what I'm gonna do is remove this filter paper from the vacuum filtration very gently. So I take my forceps and I have my little petri dish ready to go. And then hopefully what I'm gonna see when I put this under the microscope is a bunch of microplastics in there. Now to clean this out, what's happening here is this is pond water that's nasty and disgusting. Even though I have all the microplastics out, I still have to neutralize it. So I still have to neutralize the water just so all that nasty stuff doesn't go down the FIU plumbing system. All right, so to neutralize it, I'm gonna take some bleach. I'm gonna do like 3 drops, or a little bit more. And then I'm gonna swirl this around to make sure all of the liquid in there gets neutralized, and then dumping it down a sec. Okay. And then just an extra precaution, I'm gonna go ahead and rinse this out because these tend to get clogged. So rinsing it out, and then that's it for the vacuum filtration. All right, so this is the dissecting microscope that we're gonna be working with for this lab. It's a lot simpler to use than your compound microscopes. All you really do is you turn it on, you turn both of your light sources on, and you basically control using the focusing knob and then the zoom in knob. All right, so the first thing you should do when you get these is measure your field of view. So I'm gonna make sure that on my microscope, I'm on the lowest magnification, which for the dissecting microscope is 8x or 80 total magnification. I'm gonna put my ruler under the microscope and measure across the circle. So this field of view is basically how much I can see at the lowest magnification. And for this microscope, it's about 2.5 centimeters, 25 millimeters. I'm going to need that information for my field of view calculations once I start zooming in. So let's go ahead and put our sample under the microscope to see what I can find. Okay, so I found this thread. So these threads are classified as fibers, and I found it at 35 magnification, so 350 magnification total. Okay, so for the calculations when we're looking through the dissecting microscopes, the first thing that we have to establish is our FOV low. So when we say FOV, that stands for field of view, and it's essentially when you look through the microscope and you see the little circle and you're looking at whatever you're observing, you have to measure it to see how big that is. So to do that, you go on your lowest magnification, which for the dissecting microscopes is 8x. To get your total magnification, you just times 10. So the total magnification is 80, and then for the compound, it would be 40. So those are your lowest magnifications for both microscopes. Today, we're only working with the dissecting ones, so we're only using that 80 magnification. So I'm gonna put my microscope at the lowest magnification. I'm gonna slide a ruler under it and measure this. The rulers that were provided are in centimeters, and we need this measurement in millimeters. So when I put the ruler under the dissecting microscope, I find that this is 2.5 centimeters, which is equal to 25 millimeters. So the length of that circle at my lowest magnification will be plugged in over here. So my FOV low, I just measured, was 25 millimeters, times my magnification low, which again, since I'm using a dissecting microscope, is 80, equals my FOV high, which is what I'm trying to figure out, times my magnification high. So for my magnification high, it's pretty easy to figure it out. When I'm zooming in and I find a microplastic under the microscope, I look at my side scroll and it'll tell you how magnified you are. So for example, the fiber that I found earlier, I found it at 35. That would mean 35x. The total magnification that I found that at was 350. So that would be my magnification height. And I would simply plug that in. So 25 millimeters times 80 equals FOV high, which is again what I'm trying to figure out, times my magnification high, which I established was 350 because that's where I found that fiber at. So now all I do is I solve for the FOV high. This comes out to 2000 equals 350 times, again, that number that I'm trying to figure out. Divide, and then my FOV high equals 5.7, always in millimeters. Once I have that value, I just estimate how many times across my circle that item would fit. So in this case, when we looked at that fiber, I would estimate that it would be around 10 times across. So to find the size of the actual fiber, all I do is divide 5.7 by 10. And it would give me that my fiber is 0.57 millimeters in size. And so all you would do after this is find 10 more examples of the microplastics and figure out their size.